Today we will be going over fluid and pressure. Pressure is expressed as force divided by area. Now our units for pressure will be measured in Pascal. As we scroll down, we're able to see that we have a new expression, and it's read to be pressure is equal to rho times gravity times height. The reason why we have this new expression is represented here down below in the following. So first, pressure is read to be force divided by area, as mentioned up above. Now we know that we can rewrite force to be mass times gravity divided by area. Now we know that with our density, density is equal to mass divided by volume, and we can rewrite our volume to be our area times our height. So now density is said to be mass divided by area times height. Now our mass is said to be rho times area times height. Now when we derive both of these equations, we're able to plug it back into our original equation, and pressure is said to be rho times area times height times gravity divided by area. When we cross out these areas, we're able to see that our pressure is now said to be rho times gravity times height. Now for this table, you're going to be solving for your missing variables using the simulation. Now, when it's asking for the missing variable, you're going to be using your simulation to figure out the missing link. Now, as we look at this screen, we're able to see that there are two knobs. The bottom knob is going to release water. When we grab this knob, pull to the right, we release the water. For the top knob, as we grab it and pull to the right, we're able to fill the liquid. Now all the way to our left, we can notice that there are different containers. Disregard the bottom three containers. Make sure that for this experiment we're using the top one. As we move over to our right, we're able to identify our fluid density box and our gravity box. Now in order to change the fluid density and the gravity numbers, you're going to grab this blue knob, put it to either the right or the left, or to get a more accurate reading, you can use these clicks, these arrows to click and get an accurate number. Same with your gravity. Hold and click to get a more accurate reading. Now as we move up, we can see that by activating our pressure, we click and drag over to our fluid. We will be needing our ruler for this experiment, so go ahead and click the ruler box. We also will not be using atmospheric pressure, so go ahead and turn that off. We will only be focusing on our fluid pressure. Now for example, if we had our gravity equaling 8, our fluid density equaling 1,127, and our height at 2 meters, we're able to see that our pressure at a gravity of 8, a fluid density of 1,127 kilograms per cubic meter, and our height at 2 meters, our pressure is 18.5 kilopascal. Now when we're measuring our height, your zero mark has to be at the water level. So if our height is going to be 1, we know that our zero mark is at our water level, and our pressure knob is going to be directly at 1.